Now let's see the solution of this problem. Okay, we are supposed to solve the system of equation. So we have three equations here. All of them are linear, and let us see how the solution works. I'm going to solve this question completely step by step. Okay, so first we will rewrite all the equations as Ax is equal to 0, where A is the coefficient matrix. Okay, where we write down all the coefficients, it's going to be 1, 1, minus 1, 1. That's from the first equation. From the second equation, it is 1, minus 1, 2, minus 1. And the third one is 3, 1, 0, 1. All the coefficients are here. Now, X is going to be the variable matrix, and we have four variables here: X1, X2, X3, and X4. And right-hand side is all 0. I can just write down 0 for this. Okay. Now, once we get it in this particular form, we have to reduce this to a row echelon matrix. Now, we will perform row operations here. And the target is very simple, that this is the diagonal of A. And what we want to do is we want to make this 0, we want to make this 0, and this 0. And once we get it in this particular form, we call this a echelon form of a matrix. So let us reduce this to a echelon form. Now see how that works. First, you will reduce R2. That becomes R2 minus R1. Now, I am only focusing to make this 1. I want to make this 0. Okay, so I just have to do this minus this. 1 minus 1 will give me 0. So for that, I have to subtract R1 from R2. So I have to do R2 minus R1. And then I'll get this as 0. Now the next step here is going to be for row 3. And row 3 is going to be row 3 minus 3 times R1. So that is going to give me this as 0. So first my focus is to reduce these two into zeros. So let us write down the simplified version of this matrix. It is going to be, now I'll write this as X, right hand side is 0 anyways. So the first row is 1, 1, minus 1, 1. And I have made these two zeros. Okay, let's perform this operation first. We will do R2 minus R1. So subtract row 1 from row 2. 1 minus 1 is 0. Then minus 1 is minus 2 over here. Then 2 minus 1 will be 2 plus 1, that is 3. And minus 1 is minus 2, right? And next, let's do R3 minus 3R1. So to multiply R1 by 3 and subtract, or you can multiply R1 by minus 3 and add. I hope you know this already technique here. So let us multiply R1 by minus 3. So if I multiply by minus 3, this will become minus 3. And I'll add here, this gives me 0. Okay, so now the next is going to be multiply by minus 3. And minus 3 plus 1 is going to give me minus 2 here. Then multiply by minus 3 should give me 3 here. 3 and 0 is 3. And multiply by minus 3 is minus 3. And 1 is going to be minus 2. So we have got the reduced form. Okay. Now you can clearly see that row 3 and row 4 are same. Sorry, row 3 and row 2 are same. So let us do R3 minus R2. So it will all get simplified. So I'm going to use the right hand side space for that. And let us do R3 becomes R3 minus R2. So when we do that, okay, this is going to be 1, 1, minus 1, 1. The first row is same. 0, minus 2, 2, 3. That is also same. Minus 3 and minus 2. Sorry, that is also same. And the last row, when you do R3 minus R2, this will become all 0. Okay, times X is equal to 0. Now, if you carefully see this, this is the diagonal of a matrix. And since all the values below diagonal are 0, this form is called as an echelon form of a matrix. Or we can also call it as a row echelon form. Now, as soon as you get this in the row echelon form, now it's time you can rewrite all these equations. So let me do that. Rewrite equations. So if you have to rewrite this equation, I will do row multiplied by column. Now understand your X is basically X1, X2, X3, X4, right? Originally that's the variable matrix. I just wrote it as a short form capital X. Now let's multiply row by column. So you will get this as 1 into X1, that is X1, 1 into X2, that is X2, then minus X3 and plus X4 equal to 0. That's the first product here. Now let's multiply second row with this column. It will be minus 2X2 plus 3X3 minus 2X4 is equal to 0. That's the second product here by row with this column. and the last one is anyway 0. So we're just going to get these two equations. Now there are a few observations that I want to make here, and I want you to note these points. That if you see the row echelon form, okay, from here the rank of A, row of A can be read as rank of A, and rank of A is 2. Okay, so that is nothing but R. And if you see the number of variables, how many variables we have? We have 4 variables. From here, I say n is 4. Those are basically number of variables. So R is equal to 2, the rank of A, and n is equal to 4, that is number of variables. Now, since rank is less than number of variables, okay, we can have a non-trivial solution to this. So we will see what that means here. Also, when you have rank and rank is less than n, we can find out number of parameters. So let us find parameters, and formula for finding parameters is going to be n minus r. It is a difference of these two. So it is 4 minus 2, that is just 2. And let the parameters be t1 and t2. Let me assume t1 and t2 as the parameters. So now what we do with the parameters is we can assume any of the variable as t1 and any other variable as t2. That is completely your call, but I'm going to do it like this. Let us say x3 is t1 and x4 is t2. We can assume this for any of the two variables. So when I say x3 as t1, okay, we can just substitute these values in this equation here. We can make x3 as t1 and x4 as t2. So you'll get x2 from here, right? So let me write that. So from this equation, okay, if I put these two values here, I'll get minus 2 x2 plus 3 t1 minus 2 t2 is equal to 0. Okay, that's the first equation I've got. So I can write this as 2x2 is equal to 3 t1 minus 2 t2. Therefore, x2 is going to be 3 t1 minus 2 t2, and I basically got a x2 value like this. So this is the x2 value. Now, as soon as I get x2, okay, let me use this space over here. I can now use the first equation, which is x1. X2 we already have, right? So the value of x2 is going to be 3t1 minus 2t2 divided by 2. And then next is x3. x3 is t1, right? So from here, I know x3 is t1. So I write that as t1. And x4 as t2. So the last one is going to be t2 equal to 0. Now we can just like rearrange these terms and write down x1 as we will take everything on the other side. It will be t1, the minus will become plus t1 minus t2 plus 3 t1 by 2. I'm writing this as 3 t1 by 2 minus t2. Okay, and then finally x1, if we simplify, it will become this is plus t2, right? So you have minus t1 and plus minus t2 and plus t2 getting cancelled out, and then this is t1 plus 3 t1 by 2. So if we solve that, it is going to be minus t1 by 2. Now that's the value of x1. So now from all these values, I can write down the final answer, and it is like this. Okay, I'll write down the final solution to this problem. Okay, the solution, let's use this place. The solution here is going to be the values of x1, x2, x3, and x4. And those numbers are, the x1 is minus t1 by 2, x2 is 3 t1 minus 2 t2 by 2, x3 is t1, you can see that here, and x4 is t2. So this is t1 and this is t2. So finally, this is the answer we have got. Now there is one point you to understand, that t1, t2 are basically parameters. So t1, t2 can take any real value. So it can be any real value that we will mention here. And depending on what is t1 and what is t2, you will get different solutions. For example, if you have t1 and t2, both of them are 0. Okay, then the answer over here at t1, t2 both 0 is going to be 0, 0, 0, 0. Now, what if you put t1 and t2 both of them as 1? Then the answer will be minus half. Okay, then this will be 3 minus 2, 1 by 2, half, 1 and 1. So depending on the values of t1, t2, you will get different answers. And how many such solutions you will get? You will get infinite such solution. So that's basically simply means that we will have infinite solutions, and this solution is also called as a non-trivial solution because we have a non-zero solution. Okay, so let me highlight that. Now if you see this one here, okay, this is called as a non-trivial solution. What I mean to say by non-trivial solution is simply means that it is non-zero. So that you will definitely get some values which are non-zero, and that is called as a non-trivial solution. So in this problem, we have a non-trivial solution. And just remember that if you want to get a non-trivial solution, there is a condition. The condition is the R, the rank of A, has to be less than N. That is number of variable. If this condition is met, you will get non-trivial solution. And it's a good thing. A trivial solution is all zeros, right? Which is not something that is very useful. But instead, we will prefer R to being less than N so that we get non-trivial solution. I hope you followed this problem.